Okay, so this is on page 4. It looks super similar to the problems that we were doing in that it gives me a piece of cosine. The problem is cosine's not by itself. So it's like solving a basic equation, like a linear equation. I need to get cosine alone. And so if I want to get cosine alone, like I just want this, it means I've got to get rid of the 6. Okay? So right now it's like 6 times the cosine of theta. So to get rid of the 6, I can do the opposite of times. All right, so the first thing I'm doing is getting whatever that trig function is alone. So right now I'm dividing out the 6. So what's left over is this. All right, so I'm dividing out the 6. Now I've got the trig function alone. And from here, I want to graph something, but I don't really have a lot of information. On the problems that you were doing, for some of you that were doing it for the warm-up, right, there was this piece of information, cosine equals 5/6. And then there was another piece of information, tangent is greater than 0. I don't have the second piece of information here. That means that there's actually going to be 2 answers, because there are 2 places where cosine can be negative. So for all of the ones we're about to do, there's going to be 2 answers. Now before I get to those 2 answers, I can solve for theta here. So if I wanted to get rid of the cosine, what I could do is the cosine inverse. But I'm not going to do the cosine inverse of negative 5/6. Remember how I said, like, when you're putting something in here, we're talking about sides of a triangle, and the negative 5 is direction. It's not actually the side length of the triangle. So when I do the cosine inverse here, I'm going to do it of 5/6. I'm not going to put the negative in. All right, so when you are taking the inverse of a trig function, what goes inside the parentheses should never include a negative. Because when you're taking the inverse of a trig function, you're taking the inverse of side lengths. Side lengths can't be negative. All right, so when I put this in my calculator, I'm going to do the cosine inverse of negative 5/6. That's going to give me what theta is. All right, you got to make sure that when you do this, you are in degree mode in your calculator. Most of your calculators are probably already there, but I reset mine, so I'm not. So I'm changing myself to degree mode, and then I'm doing the second cosine of 5/6. I'm not doing negative 5/6. You will not get the same answer. Okay, so don't do negative 5/6. You're just doing 5/6. 33.56 we'll call this. So theta equals 33.56. Now I'm leaving space next to theta because what theta is the reference angle. The reference angle is 33.56, and I'm getting that, so if you're just coming in, I wanted to get this equation so that cosine was alone, so I divided out the 6. And then to get theta alone, I had to do the inverse of cosine. That clears out the cosine. I'm just not including the negative. So this theta itself is the reference angle. What I'm looking for is the standard angle. All right, so from here, I'm going to run in all students take calc. For where cosine is negative. Negative because of this. Cosine is negative 5/6. So where is cosine negative? Well, it's positive in 1 and 4, which must mean it's negative in 2 and 3. So I'm going to have a quadrant 2 answer and a quadrant 3 answer. From here, you can draw a picture or you can use the rules. For right now, I'm going to draw the picture so you can see it, but eventually a lot of you are going to stop drawing the picture and just use the rules. All right? So in quadrant 2, here's what this means. I've got some angle in quadrant 2, and if I were to make the reference triangle for that, it would look like this. And cosine is adjacent over hypotenuse. So if this is my reference angle, the adjacent leg is negative 5, and the hypotenuse is 6. I could similarly make a triangle in quadrant 3. So some angle in quadrant 3, where I make that reference triangle, and the adjacent side is -5, and the hypotenuse is 6. Both of those triangles went to the left, so the x is negative. The hypotenuse is 6. You okay with that? Now, on the stuff that you did for the warm-up, on the stuff that you did yesterday, you needed to find the third side length. You don't need to find the third side length for this problem. What I need you to find is this and this. So you can do that visually from this picture, or you can do it from the rules. You know what this is. Right? This angle right here is the reference angle. This angle right here is 33.56 for both pictures. Now I'm just going to apply the rule. So in quadrant 2, the rule is my reference angle plus my standard angle together make 180 degrees. So if I know that the reference angle is 33.56, I can solve for that standard angle by subtracting 180. And if I'm in quadrant 3, the rule is 180, so that full half circle, plus that little bit, which is the reference angle, equals the standard angle. So 180 plus the reference angle I know, 33.56, equals my standard angle. So I'm just going to solve both of those two equations for S, and that's my final answer to the problem. There are two answers to the problem. So I'm going to do 180 minus the 33.56 and 180 plus the 33.56. Strictly because we're in quadrants 2 and 3, the rules will change when the answers are in different quadrants. So the two answers to this problem are 146.44 and the second answer was 213.56. And you can check both of these answers. Think about like when you solve a linear equation. To check your answer, you just take whatever you get for x and you plug it back into the equation. I can do that here. I can do the cosine of 146.44 and the cosine of 213.56, and they should both equal roughly -5/6. So just to show you, cosine of 146.44, cosine of 213.56, both of them roughly equal -5/6. Now they're not perfect because they're rounded, but they're close. So you can check your answer at the end. All of these problems have two answers. Sometimes those answers are in quadrant 1, sometimes they're in 2, sometimes they're in 3, sometimes they're in 4. It depends on what the given information is. All right? So let's look at the next one. The first thing you have to do is you have to get the trig function alone. So that 7 in front has to go to the other side. So to get rid of the 7, what I'll do is I'll divide out 7 so that I have sine of theta equals -2/7. Once the trig function is alone, you're going to find the reference angle. And you find the reference angle by doing the trig inverse of whatever's on the other side. But when you do that, don't use negatives. That's just like a tricky step to it. So I'm not doing the trig inverse of -2/7, I'm just doing the trig inverse of 2/7. That's going to give me my reference angle. All right, so sine inverse of 2/7. So it's second sine of 2/7. 16.6. All right, so I need the reference angle to find both answers. Once I have the reference angle, then I need to pick which quadrants that reference angle is going to be applied to. So in quadrant 1, the reference angle and the standard angle are going to be the same. In quadrant 2, I'm going to do 180 minus. In quadrant 3, I'm going to do 180 plus. In quadrant 4, I'm going to do 360 minus. Some of you are going to memorize that. Some of you are going to draw pictures. Okay, it doesn't matter. But I need to figure out where I'm applying that to. So I'm gonna do this. And my sine is negative. Sine of theta equals negative 2/7. So I'm trying to figure out where sine of theta can be negative. I know sine can be positive in 1 and 2, which means it can be negative in 3 and 4. So the two answers that I end up with are going to be quadrant 3 and 4 answers. We okay with that? Now, if it doesn't make sense to you to just immediately go to the quadrant 3 and 4 rules, you can draw quadrant 3 and 4 triangles. So a quadrant 3 triangle has some leg in quadrant 3, and a quadrant 4 has some leg in quadrant 4. And then when I'm making the triangle, I'm using the x-axis. So this pink angle right here, that angle is the 16.6 for this one, for both of those triangles. What I need is the green. You can see it's going to be different for each of those. All right. So in quadrant 3, 180, this half circle, plus this little piece, which is called the reference angle, together make that really big angle. And in quadrant 4, this really big angle, which is called the standard angle, plus this little piece of pink, which is my reference angle, together make a full circle. Each quadrant has its own rules. Whether you choose to memorize them or use the picture is up to you. You do not have to draw the picture for these problems. You can just do the work. So for this problem, I'm going to do 180 plus my reference angle, which I figured out was 16.6 to find my standard. And for this one, I'm going to have to solve for my standard angle by subtracting 16.6 from 360. My result will be 2 answers. Those are the answers to the problem. So 180 plus 16.6 and 360 minus 16.6. Those are my 2 final answers. 196.6 is answer 1, and answer 2, 343.4. You can check them. You can plug both of those back in right here and see if you get negative 2/7. So I'm going to do a sine of 196.6 and a sine of 343.4. It's not perfect, but it's pretty close to that same decimal. That's just a check. All right, let's look at this one. The math of it is a little bit trickier, but the idea of it is the same. I'm trying to get this by itself. What do you think I do first? Subtract 5. So I'm going to subtract 5 from both sides. I'll have 4 sine theta equals 3. And then I'll divide by 4. Sine of theta equals 3/4. So step 1, get the trig function alone. If there's anything on the outside, get rid of it. Step 2, find the reference angle. You're going to find the reference angle by doing the trig inverse. If the fraction's negative, you're not going to include it, but this one isn't. So I'm just going to do the trig inverse of 3/4. This is going to give me my reference angle. Your reference angle should be something between 0 and 90 degrees. It's an acute angle. So sine inverse of 3/4, you just want to make sure you're in the degree mode. So 48.59 is my reference angle. So get the trig function alone, find the reference angle. After you find the reference angle, you're going to apply it to this. So I have that sine of theta equals 3/4. So I have that sine of theta is positive, because 3/4 is a positive number. So I need to pick the two places where sine is positive. Sine is positive in all and S. So from here I know I'm going to have an answer in quadrant 1 and an answer in quadrant 2. If you know the rules, then you don't have to draw the picture. If you don't know the rules, then draw an angle in quadrant 1 and draw an angle in quadrant 2. And you can see it then, all right? So if this is my reference triangle, this is my reference angle, and I know that that angle in pink is this 48. That's the reference. What I'm looking for is this. And I can see from my picture here that in this quadrant, R and S are the same thing. Right? They're the same exact measure. So my first answer to this problem is 48.59. I don't have to do any work when it falls in quadrant 1. In quadrant 2, I see that my pink angle plus my green angle make a half circle, which means together they're 180. And I know that this reference angle is 48.59. So I can subtract 48.59 from 180 to get this angle. So 180 minus the reference angle in quadrant 2, that's your rule, 131.41 is my second answer. Your final step, which doesn't have to be a step, but it's just a check, is to take those two things and plug them in for sine, and hopefully we get 3/4. So hopefully we get 0.75. So sine of 48.59 and sine of 131.41. Both of those things are about the same decimal as 3/4. If they're not, then you did the wrong thing. You either applied the wrong rule or you have the wrong reference angle. What do you guys think? There's one more in your toolkit, but I'm gonna have you just try 1 or 2 on your own. Actually 1. I'm gonna have you try 24. And then I'll do 23 with you because it's a trig one. So try 24 right now. Just know that your final answer, whatever you're circling, there's 2 of them. There should be 2 final answers here. This is on page 18, I think. Does that look like page 18 to you? All right. So page 18, try 24 for right now.
I'm fine with like the whole rest of the problem if we start. I mean, like get this.
So you can either divide by 0.5, but that's the same as multiplying by 2. You can multiply by 2.
1 plus
3/4 times 2 and get rid of the 1.
Alright.
Yep. Or you can change it to a decimal and divide by 0.5. You can't divide by 1/2 in your calculator, but like you could make this a 0.5.
And then you just leave it as an proper fraction.
Yes, so you could change that to a 0.5. And divide by 0.5. You should end up with an improper fraction. I think it's 3/2.
Yeah.
Right. So then from that point, find the reference angle, pick your quadrants, apply the rules to the quadrants. Yep, you don't need that picture if you don't want.
Lots of users,
Yeah.
as long as I haven't had it.
That's your answers. Yep, your two answers.
I thought that was much easier than the last one you said.
You do?
To me, it really.
Now last unit was stuff you learned before. Thought that
Well,
was
'cause
easy.
I don't really know stuff you learned prior to.
Fair enough.
So, the final is fourth cases, right?
Plus,
Would be one fourth.
correct, that's all you gotta do. And you're gonna, so you're gonna rewrite it as sine. All right, so maybe if you weren't sure how to get rid of the 1/2, I changed it to a 0.5, but you also could, the opposite of dividing by 1/2 is multiplying by 2. So you could have multiplied the other side by 2. Ultimately, we end up with tangent theta equals 3/2, or 1.5 is fine. You could write it as 1.5. So to find the reference angle, I'm gonna do the tangent inverse of 3/2 or the tangent inverse of 1.5, whatever works. That's gonna give you your reference angle. Tangent is positive because 3/2 is positive. So I picked 1 and 4. Now I'm not going to use a picture. I know quadrant 1 is the same. So I know that this answer is 56.31. And if you memorize the rules, quadrant 3 is 180 plus the reference. So I'm going to add them. Now you can draw the picture, that's totally up to you. Or you can just work on knowing these rules. 1. So that's 236.31. This problem is double the problem you did yesterday. Because the problem you did yesterday with that second piece of information, it was like tangent theta equals 3/2, sine is positive. So sine can't be positive in quadrant 3. So the stuff we did yesterday was just the first answer. These all have 2 answers when you don't have like the 2 pieces of information. Now, if it looks like this one, we didn't do one of the reciprocals, you're still going to get the cotangent by itself. So you're still going to divide out the 5. Like that. Like you're still going to work on getting the trig function by itself. But you can't find the reference angle from that because there's no cotangent button in your calculator. So you have to change that to the type of trig function that's in your calculator. You either need to change it to sine, cosine, or tangent. This one is a tangent. So I will change it to tangent. And the way that we change it is we flip the fraction. So if the cotangent is -7/5, the tangent is 5/-7. So I still get the trig function alone, but if it's a reciprocal, I just have to rewrite it as its reciprocal function. And by rewriting it, I'm flipping it. So then from here, I'd find the reference angle by doing the tan inverse of 5/7. Remember, you're not using negatives. And then whatever you get for that, you're going to apply to quadrants 2 and 4. And the reason that I'm writing 2 and 4 is because tangent here is negative. Well, tangent's positive in 1 and 3, so it's negative in 2 and 4. So whatever that reference angle is, I'm applying it here. I didn't even do the reference angle yet, but quadrant 2 is 180 minus the reference, and quadrant 3 is 360 minus the reference. So whatever I get when I type that into the calculator, I can either draw the picture or just apply the rules. The only thing that makes this problem different is the cotangent. You might see like a cosecant. I don't need you to memorize what they go with because there's going to be a spot on your test that has all 6. And remember how I have them written next to each other? You can just find it on your test and see what it's next to. All right, so you won't have to memorize that cosecant goes with sine. It'll be somewhere on your test. Are we okay with that? All right, the only other thing that's possible is the directions change. And it says solve from 0 to 2 pi. The process is identical, except you need to hit the mode button in your calculator and you need to change it to radian mode. Because 0 to 2 pi is radians. All right, so like if I were to solve this problem, which is in your toolkit, it's toolkit problem 28. Well, I don't need to move anything. There's nothing on the other side. But I can't find the reference angle from here because we don't have a cosecant button. So to me, I gotta say, okay, well, cosecant goes with sine. So if cosecant is 5/1, then sine is 1/5, right? That's not really different. And I would want to find the reference angle from here, and to find the reference angle, I would need to do the sine inverse of 1/5, but I'm not going to do it in degree mode. If the directions say 0 to 2 pi, that's radian mode. It's going to look weird, okay? Because radians are in terms of pi, and you're not going to see the pi. You're just going to see really long decimals. So what I'll do, if the directions say 0 to 2 pi, is I'll hit mode, and I'll change it to radian. And then I'll do second sine of 1/5. My reference angle is 0.2, all right? You know how I said a reference angle needs to be between 0 and 90 degrees? A reference angle in radians needs to be between 0 and, well, 90 degrees is pi/2. So it needs to be between 0 and 1.57. So you're going to be looking at some really weird decimals when you're looking at your reference angles. So for this particular problem, my reference angle is 0.2. So let's think about what that means for the problem. So my reference angle is 0.2. So we get the trig function alone. If it's a reciprocal, we flip it. Then we find the reference angle. Then we have to pick our quadrants. So I am dealing with sine of 1/5, which means sine is positive. Sine is positive in 1 and 2. So my answers are going to be somewhere in 1 and 2. So from here, you can draw a picture in 1 and 2, or you can use the rules. I'm just drawing some angle in 1 and some angle in 2. This is 0.2. I want that. In quadrant 1, it's pretty straightforward. Green and pink are the same thing. So if the reference angle is 0.2, the standard angle is 0.2 as well. But for this one, usually R plus S equals 180. But we're not in degrees anymore. That's a degree. What is 180 as a radian? 180 equals pi. So really I'm doing that. And so the reference is 0.2 plus S equals pi. So I'm not doing 180 minus 0.2. I'm doing pi minus 0.2. And you can just type that in your calculator and you can round it because it's going to be a decimal. Pi is irrational. So second, and then this like caret button, minus 0.2. So 2.94 would be this answer. You can check it the same. Sine of 0.2 and sine of 2.94, as long as you're in radian mode, should give you 1/5.
What are the times would say for us to change?
The directions will say either 0 to 360 or 0 to 2 pi. Before the test, I'll give you a hint on what that means. But 0 to 360, 360 is degree. 0 to 2 pi is radian. You're going to have to know when to switch your button on your calculator.
So when we're doing radians for polar 4, we're basically the same thing we do, but instead of doing 360, we do 2 pi.
You would do 2 pi. That's the only difference. The process is all the same. It's just anywhere you would have done a 180, you're doing a pi. And anywhere you would have done a 360, you're doing a 2 pi. So like if I wanted to check this, I could do sine of 0.2 and sine of 2.94, and both of those things is about 1/5.
They don't have to perfectly do the same numbers.
They don't, because we rounded those, so they're not going to be. Because you're using pi, it's going to make everything round. The process is the same. It's literally a button in your calculator that you have to change. So let's just do one more. Let's do that one. You guys try that one and we'll end here. And then Monday is just gonna be a practice day of this, since obviously half the class is out, I'm gonna have to catch them up. So on Monday, you guys will work on a quiz review, and then I'll catch up the other half of the class. And then Tuesday's your quiz. I did put you all, or most of you, in my bonus block Tuesday for even more practice before the quiz. Alright, but try this one. So try to get cotangent on its own. And cotangent pairs with tangent, so when you're making the change, you're changing it to a tangent. Just remember, when you're doing the reference angle, don't put the negative in. So if you're having trouble getting started, I added the 5, and that gave me a cotangent of -3. So then the reciprocal of that would be -1/3, which would be tangent, because tangent is just flipping that fraction. When I'm doing the reference angle for that, it's tangent inverse of 1/3, not -1/3. If you do -1/3, you won't get the right reference angle. Remember, we're talking about side lengths of triangles in there. Side lengths of triangles are always positive. So when you take the inverse in your calculator, just make sure you're not using negatives. Also make sure if you hit the mode button on your calculator, you are in radian mode now. The directions for this section say 0 to 2 pi. So if you're not getting that reference angle, there's a good chance you're in degree mode still. So hit mode, change it to radian. All right. From here, all students take calc. Tangent is -1/3, so it's negative. Tangent's positive in 1 and 3, so I want to apply this to 2 and 4. Whether you do the picture or the rules is up to you. This quadrant 2 rule is that the two angles together equal 180, but in radian mode, that's pi. And in this one, the two angles together equal 360, but in radian mode, 360 is 2 pi. So I'm not going to be subtracting 180, I'm going to be subtracting from pi. The reference angle itself is the 0.32. So I'm just solving that equation. So I would do pi minus 0.32 and 2 pi minus 2.82 and 5.96. What do we think? Easy? Hard? Alright, so Monday, like I said, review. You guys will all just review. I'll check in as a warm-up and maybe do 1 or 2 with you to refresh your memory from over the weekend, and then you'll review for the quiz. That's the last new thing. So on your quiz, section 1 will be, here's an angle, 520 degrees. Can you graph that for me? So it's like, can you subtract 360? Figure out what quadrant that goes in. Can you draw a reference triangle from that and find a reference angle? Here's a coordinate point, 2, 3. Plot it, make a reference triangle, find a reference angle, and then this stuff. Alright, that's what the unit is. In terms of Delta Math, you can do it all now. If you're stuck on any of it, I did an example problem of each, and I worked that out. I put that PDF on Canvas. I also did a video explanation of how to do each for the approach, and I put that on Canvas. Your numbers will be different, so you're going to have to make changes. Your quadrants might be different. So you're gonna have to make changes, but like the mindset's the same. So if you need any of that, that's on Canvas. That's gonna be due the 5th, which I think is Tuesday.
What's the Delta lab due?
I think Tuesday. I have it as the 5th, which is Tuesday.